So in this section, we're talking about arithmetic series. Yesterday, we talked about arithmetic sequences. So it's important that you know the vocabulary and the difference between a sequence, and a series. Series is indicated sum. So anytime you have the word series, it means you should be adding a bunch of terms. So series means add all the terms. An arithmetic series is one that is the sum of the terms of particularly an arithmetic sequence. Tomorrow we'll talk about a geometric sequence, but right now it's an arithmetic sequence. So the main difference between a sequence and a series is that a sequence has commas separating them, some ordered list of numbers, but a series is you're adding those terms of the sequence. So that's the main difference. One has commas, the other has addition or plus. And the notation is a capital S with a subscript, where the subscript n is the number of terms. So the sum of n terms. So this would be the sum of 9 terms. So I want to show you where the formula comes from, a fast shortcut formula. And this formula, there's actually a story about this formula. The story is that in the 1800s in Germany, there was a young schoolboy, and he was a naughty schoolboy, and his teacher wanted to keep him distracted. So the teacher asked, I want you to add the numbers from 1 to 100. So add the numbers from 1 to 100. So add up all these, and there weren't calculators back then. So the teacher was hoping that this would keep the student busy work, keep the student busy for a while. So I want to do a similar question like this, but I just want to use a couple fewer numbers so you can see everything that happens. So let's say we have some series, and we have 9 numbers that we're adding. And we'll say that our sum is just adding from 1 all the way to 9. 9 is our last term. So if we had a sum of 9 numbers, we have 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. Now, it wouldn't take us too long to add up all these, especially with calculators, but I want to show you where a formula comes from. So let's say we had this sum, and we wanted to add 9 plus 8 plus 7. So the same sum of numbers, but now we're just going downhill. 3, 9, 8, 7. It helps if you count right. Plus 5 plus 4 plus 3 plus 2 plus 1. Okay, so here's the sum we want to know. And we could do this, again, without a calculator or anything, or without a formula. But let's say we add these two. So same sum, we're adding it twice. So you have 2 S's, 2 sums of 9 terms. And 1 plus 9 is 10. 2 plus 8 is 10. 3 plus 7 is 10. And we keep getting 10. 10, 10, 10, 10, 10. And how many 10s do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 10s. So the sum is 9 times 10 divided by 2, because we had double the sum. So divided by 2. And the reason why I'm showing you this is because 9 was the number of terms that we had, divided by 2. And 10 comes from adding the first and the last, and you would get 10 every time. So you'd have a sub 1 plus a sub 9. So with this German student who had an idea to do it this way, his name was Carl. He said, well, this would be the same. So if I add these, I would get a bunch of 101s. Specifically, I would have 101, so it would be 100 times 101, which is 101 with 00 at the end. But I doubled the sum, so you divide by 2, and that would be the sum of the first 100 numbers. So then you divide by 2, you get 50, 50, 5,050. would be the sum of the first 100 numbers. And he did that. He actually did it this way, and the teacher was really impressed. And he later became a mathematician. One of the most famous European mathematicians, Carl Gauss was his name. Carl Gauss. But you don't need to know his name. I'm just relating that somebody actually used this, and he became a mathematician later.
Will these be corners?
Okay, so the reason why I showed you this part right here is because that's the same as this formula. This is our second formula over the chapter, this formula right here. The sum of any arithmetic series is the number of terms divided by 2. So in this one we had 9 terms divided by 2. The first term plus the last term. So that's a really nice, short, compact formula. This formula it looks more complicated, but if you take the a sub n out of this formula and you substitute in this formula, or this much, and you substitute it in, it would be n over 2, a sub 1 plus a sub n. A sub n equals all of this. And you would get a new summation, a new sum formula for an arithmetic series, where you have 2 a sub 1. A sub 1 plus a sub 1 is 2 a sub 1. So that's where this formula comes from, this part right here. So notice this much is the arithmetic sequence formula. So I want you to know both of those formulas. You use them in different contexts. So you use the first one when you know n, a sub 1, and a sub n. You use this formula when you have n, a sub 1, and d. So the main difference is this one you have a sub n, and this one you have d. But notice for both, you need n and you need a sub 1. So if you don't know n, or if you don't know a sub 1, then you have to use this formula from a previous lesson, this formula right here, to figure out n or a sub 1. So let me show you how these formulas are used. It's basically plugging in numbers. You just have to plug them in the right spot. So find the sum. S sub n is the sum, so S sub n. N in this case is 26. And since we have the last term and the first term, we can use the short formula. So you have 26 over 2, 58 is the first, plus negative 7 is the last term. And then you can type it in your calculator and find what the answer is, which would be 13 times 51. 663. If you'd like to pause this video and see if you could do the next example. And there's the answer, 2646. The next example, notice that you're given D, and you have n and a sub 1. So in a case like this, you can use the second formula right here. So plugging in the numbers, you would have S sub n, the sum of 8 terms, is 8 over 2. The first term times 2. 2 times 3 is 6, plus n minus 1 times d is negative 4. And if you want to use brackets, you can. It's kind of nice to use brackets if you have too many parentheses, because it's a lot easier to look at. Negative 8. The next one is an important example because there's a problem in the next one. The problem is we have d, that's okay. We have n, we have a sub n. We need to know a sub 1 to use either formula. So if you ever are missing n, or a sub 1, you have to use the formula from section 11.1, which was this formula, arithmetic sequence formula. So we're going to use that to find a sub 1. So if you use that, we have a sub n equals a sub 1 plus n minus 1 times d. And 17 times 7 is 119. We subtract 119 from both sides, we get negative 47. And then you have a choice. You can use the short formula or the long formula, but either way, you'll get the same answer. So the short formula would be the sum of 18 terms. And see if you could finish this. So the answer is 225. So those 4 examples are basic examples. They'll gradually get more complicated, or there'll be word problems and such like that. So here's a word problem. Suppose you practice the piano 45 minutes on the first day of the semester. Increase your practice time 5 minutes every day. How much total time will you devote to practicing during the first 45 days of the semester? So you could do this the long way. The long way would be to do this. You have 45 on the first day, 45 minutes. So this is minutes. This is days. The second day, you increase 5 minutes. So that would be 50. The third day, you increase 5 minutes. That would be 55. And you keep going for 45 days of the semester. And we could figure out how much you practiced the last day. But the question is, how much total did you practice? So you have to add up. You have to add up all of those practice times. So you have 95, 150, and you keep adding. That would be the long way. The short way would be to use one of the formulas. So you would have a sub 1 is the amount of time practiced the first day, which is 45 minutes. N is the number of days that you practiced, which is 45 days. So that's this number right here. You increased 5 minutes every day. That would be D, 5 minutes every day. And A sub n, we don't really need A sub n because we have a formula that will use all these. So the formula is S sub 45 days equals 45 over 2, double the first term, which is 90, plus n minus 1, 44, times D, which is 5. And that will give you total minutes that you practice the piano. 6975 minutes. For the next one, find the sum of the series. You're given the first term, a sub 1. You're given the last term, a sub n. And you also know D. The difference between 7 and 14, 14 to 21 is 7. The problem is you don't know n. And you need to know n for either formula to work. So you have to know n. So what we're going to do is use this formula, the arithmetic sequence, and we're going to solve for n. We're going to solve for n in this formula. So we would have 98 equals the first term plus n minus 1 times d, which is 7. And you'd have 98 equals 7 plus 7n minus 7. The 7 minus 7 is 0. 98 equals 7n. 7 goes into 9 once, with 2 is 4. 14 terms. So there are 14 terms. And to find the sum of 14 terms, now you can use the short form for arithmetic series. So you'd have 14 over 2, and 7 plus 98, which is 105. 105 times 7 is 735. And pause this video and see if you can do the next example. So the answer is negative 204, where n is 12, negative 204. You can continue this lesson on the next video, 11.2b.